Alright, okay, so let's continue with subtopic 1.4, charge in uniform electric field. So basically, a uniform electric field is formed when there are two parallel plates which has opposite sign, positively and negatively charged at a distance d. So a uniform electric field can be produced by two parallel plates either horizontally or vertically as in figure. So the direction for the uniform electric field will be from positive plates to negative plates, and the value of the electric field along the two parallel plates is always constant. Okay, so to calculate the value of the uniform electric field, we can apply equation number 9, which is given as E electric field equals to negative delta V, as in the change in the potential, the potential difference divided by the distance between the two plates. So the negative sign indicates that the value of the electric potential decreases in the direction of electric field, as the direction of electric field moves from positive to negative plates, the value of the potential decreasing along it. Okay, so that is why the shape of the graph is decreasingly down and the negative sign occurs. However, to obtain the value of electric field, we can ignore the negative sign. So equation number 9 can only be applied for parallel plates only. Okay, if you have an isolated charge, okay, iaitu charge yang individually, that means kita guna formula nombor 3, KQ over R squared. Okay, so from the equation, okay, we can derive to get another unit for electric field, which is volt per meter, iaitu Vm negative 1. But if you want to use the unit that we have derived from equation number 2, which is Newton per Coulomb, is also the same. Okay, so underneath this subtopic, we have 4 different cases that can apply the concept for uniform electric field. Okay, so let's start with case number 1, which is stationary charge. Okay, so we consider a particle of charge Q0 and having a mass m held stationary in a uniform electric field. So when we have two parallel plates with opposite charge, positive and negative, it will produce a uniform electric field. And if there is a particle with a magnitude of charge Q and mass m held stationary inside, so the particle will experience two forces, okay, which are W weight, always acting downwards, and electric force Fe, which has to act upwards. Okay, so that the two forces are balanced, and hence the charge can be in stationary state. Okay, so since the particle is stationary, that means we apply the first Newton's law, total F equals to 0. Therefore, the force upwards Fe will balance with the force downwards weight. Okay, then the second case that we have, charge in dynamic equilibrium. So if the particle's vertical acceleration is 0, as in Ay equals to 0, it moves in a straight line with constant velocity. Okay, so it is almost similar case to stationary charge. However, in this case, the particle is moving horizontally, okay, in a straight line, exiting the two parallel plates. Okay, because it is still under equilibrium, that means the net force must be equals to 0, and since the two forces acting in opposite direction, therefore Fe minus W equals to 0. Okay, so the charge will be able to travel without deflection. Okay, next we have charge moving parallel to the field. So if the charge is able to move alongside with the electric field, as in parallel to the field, that means either the upward force Fe or the downward force W is bigger than the other. So that is why it is able to accelerate. So in this case, we will apply Newton's second law, where we have total F equals to ma. So depending on the direction, which force is higher than the other, you can calculate what is the acceleration of the force. However, if it is electron, if Q is electron or protons, then W is negligible. Okay, so besides moving parallelly, charge can also move perpendicularly to the field. Okay, so in this case, if the charge is moving perpendicularly to the field, that means the charge has the ability to be deflected upwards or downwards, depending on which force is bigger than the other. Okay, so if you need to solve problems related to this scenario, then you have to consider all the components, okay, either x component horizontally or y component vertically. Okay, so usually this subtopic is not complicated and not asked in exam that much. Alright, however, let's look at question to test our understanding.